Hello, good day my people. I hope each and everyone is cool, right? Okay, so welcome to today's lesson, and in today's lesson we are going to be looking at combination of binary operations and modular arithmetic. Please, are we getting that? So I think we are familiar with what? Binary operations, right? We are having so many words operations in mathematics. We can give you what? A plus B. And you know this is combining the A and B. We have that of the multiplication, division, subtraction. They are all what? Binary words operators. Are we getting that? Sometimes you can also be given, let's say, A, then what? We will define the operation. B, which is equal to, let's say, 2AB plus 1. So before you can combine this, we use this machine. And combination of A and B using a machine of this sort, a situation whereby the operator is defined on the machine, is what we call what? Binary word operation. So in binary operations, we have two things that we are combining, but we combine them using what? A machine. On what? Undefined operator. Please, are we getting that? Okay, so that is that. So let's now see through how do we solve what? Binary operations combined with modular arithmetic. Are we getting that? Let's begin with example number 1. Let's begin with example number 1. And example number 1 says, and it says the binary operation star is defined by A star B, which is equal to AB plus 2. In arithmetic modulo 5. Hey, we have to draw table for the operation star on the set 1, 2, 3, 4. B, we have to use the table to I evaluate 2 star 1 plus 2 star 3. I find the truth set of n star 3, which is equal to 3. So solution, and that is that. So what do we do now? This is what we have to solve, and it says the binary operation star is defined by A star B, which is equal to AB plus 2. In arithmetic modulo 5, we have to draw a table for star on the set this. Please, are we getting that? Then the B says we have to use the table. So let's focus on the table in the first place. So here we can see modulo, we can see what's given a set And what are we going to use to combine the values in the table? Are we getting that? And we use what? That of binary operation. So A star B should be equal to what? AB plus what? 2. That's what we are going to use in filling what? The table. So we said we don't know the star, whether it is addition, that is a machine. So to combine this and that, we use this what? Machine. Please, are we getting that? And that is what? Binary operation. So binary operation combined with what? Modular arithmetic. How do we do that? So we already know that for the set, we have what? 1, 2, 3, 4. We don't have 5 because we are in modulo 5. 0 was supposed to be part, but we said what? This is what they chose for you. Are we okay? Are we okay? So let's now proceed. So what do I put here? I put the star. That is the operator. Here is neither plus nor what? Multiplication. But we use star. Then we have 1, 2, 3, then the 4. Also 1, 2, 3, then the 4. So I have this one coming this way. Okay, nice one. Okay, so that is our ninth table. And how do we fill this? How do we what? Fill the table. So we are going to say what? 1 star 1. 1 star 1. Are we getting that? So if I say 1 star 1, meaning this is A and this is what? B. So wherever I see A, I put what? 1. And wherever I see B, so I put what? 1. So if I come here, it's going to be 1, 1. So wherever I see A here, what do I put here? 1, and here 2 will be 1. So it should be 1 times 1 plus what? 2. Then I put the answer here. Are we okay? But here, we are going to put it on our calculator. We are going to put it on our calculator. Are we getting that? We want to put this machine. A star B is equal to this machine. So that always we will not put the number times. Are we getting that? So see how we are going to do it. We are going to put A, B plus what? 2. Are we getting that? On the calculator. Calculator is having what? A, B, C, D, X, Y, Z. But we are familiar with what? X, Y, Z. So whatever that we see here, we imagine this is what? X and this is what? Y. So when we come here, this one too is X and this is what? Y. Are we getting that? We are imagining this is X, this is Y because calculator is having A and B. But we want to be using what? The X and Y. Or yes, so we can use the A and B. Are we getting that? So I have AB plus 2. Are we okay? So I can put AB plus 2 on the calculator. And by doing that, we have what? The A, B, C, them things. The color is what? Pink. I don't know that of your color. And mine is pink. So we click on the alpha before that. That one is what? Activated. Are we getting that? Okay. So we click on that before that one is what? Activated. So I click on alpha, then A. So I can see A. I also have what? B. So times B. But I'll say what? Alpha again and B. Then plus mine 2. So plus mine 2. Then what do I do next? Now I want to calculate for what? Value for A and B. Are we getting that? So meaning I go to calc on the calculator. Click on the calc. Then we have A question mark. You see what you are having on the calculator is A, B plus 2. So immediately you click on the calc, you see A question mark. So it is asking you, what value of A do you want to put? What value of A do you want to put? That is what you're asking. Now we are saying that these ones are representing the A and these ones are representing what the B, because we said in the modular table that these values are for the first one, so we operate this on that, but not this on that. So this one is operating on this. So this one is the first, and this is the second. This is the first, this is the second, this is the first, this is the first, this is the second. Please, are you getting that? So all the values here are the first values, and these are the second one. When we come here, A is the first, and B is what? The second. So all the values here are for A, and those here are for what? B. Please, do we get that? So I want to take 1, 1. So A is 1, and also B is what? 1. So I'll put what? 1 Then I click on equal to. Then B question mark 2 has come. Are we getting that? So what value of the B? Then that one too, I put what? 1. I click on equal to. Then I see what? 3. I see 3. But we are working it in mode 5. Are we getting that? So I'm seeing what? This 3. Are we okay? So let's now continue. So I'm having 3, and I can also solve it manually. Here is 1, here is 1. 1 times 1 is 1 plus 2 is 3. Then you click on the equal to again for the A question mark to what? Come again. Okay, so I have A question mark. Now I want to take this and that. So A is now what? 1. Then equal to B is now what? 2. Then I put here what? The 4. The answer is 4. In mode 5 is what? 4. Are we getting that? Then I come to what? A, the same thing and that. So I'll have the equal to, then A now is what? 1. And B now is also what? Now 3 for here. So I put my 3. Then I get 5. We are in what? Modulo 5. So 5 is not supposed to be here. So I put what? 0. So 5 mode 5 is what? 0. And I think we are okay with that. Okay. Then the next one is 1 and then the 4. So equal to A1 and B is what? 4. Okay. So I have 6. And 6 mode 5 is what? 1. Please do we get that? Now I'm coming to the second one. So I have 2 operating on all this. So 2 is for the A and what? Now the B's. So 2, 1. So I'll have equal to A question mark. A is 2. Then B is what? 1 for here. So I put 1. Then equal to. Then it is getting me what? 4. Then I continue. 2, 2. So equal to A to be 2 and B to also to be what? 2. And that one too is getting me 6. 6 in mode 5 is what? Is what? 6 in mode 5 is what? Is 1. Then I have what? This and that. So 2, 3. So I'll have 2 for A, then 3 for what? B. And that one too is getting me 8. 8 in mode 5 is what? 3. Then shall we proceed? Then 2, 4. 2 for A, then what? 4 for B. And that one too is getting me 10. 10 in mode 5 is what? 0. Please do we get that? And I know now you've gotten the concept, so you can pause and continue, right? Okay, so to continue, what do we do now? I'm taking this, operating on this. So 3, 1. So equal to, then 3 equal to 1. So I get 5. So here is 0. Then 3 and 2. So A, 3, B, 2. That one too is getting me what? 8. So I'll have here to be 3. 8 mode 5 is what? 3. Are we getting that? We are working these numbers in mode 5. Okay, then I have 3 words and 3. So A3 equal to B3 equal to then 11. 11 in mode 5 is what? 1. Please do we get that? Okay, then I'm having this one that is 3, 4. And that one too is getting me what? 3, 4. So I'll have 3 for A and 4 for B, which is 14. 14 in mode 5 is what? We know it's 4. Is that not it? That's the remainder. After 5 goes into what? Or after 5 going into what? 14. Are we getting that? So then now 4 and this one. So 4, 1. So I have A4, then B was 1. And that one too gets me 6. In mode 5 is what? 1. Then the next one is I have 4 and 2. So A is 4, B is what? 2. Then that one too gets me what? 10, which is 0. Then what's next? Then I have 4, 3. So I take my A to be 4 and B is what? 3. So that one too is getting me 14. In mode 5 is what? 4. Please do we get that? Okay. So the next one also says this one. That is 4, 4. So A is 4. Which is equal to B is also what? 4. Then I have what? 18. So 18 in mode 5 is what? 3. Please do we get that? Let's proceed. But can you see something? when I take what, I operate this on that, before I write the answer, sometimes you forget that you are operating it on what? A modulo. Are we getting that? So what do we sometimes do? We know what? After operating this on that, then we take the modulo of that. The modulo, we said that one to taking a modulo of a number to get the remainder. What do? We get the number, then we divide by what? The modulo. Are we getting that? So we know the number, to get the number is from where? AB plus 2. That is what will get us what? The number. Are we getting that? So some people can directly say what? The AB plus what? The 2. It's not always that whenever you take the modulo and this one I said what? It was 4, 4, 6, 3 plus 2, which is 18. And some people don't know 18, the remainder, unless they say 18 over what? 18 over what? The 5. Then they use the mixed fraction word, the idea of the mixed fraction in getting the answer. So how can the person now claim or clear whatever the person has put to do the calculation? Are we getting that? We are having the AB plus 2 on the calculator. Now you want to, you put and you have what? 18 over 5. Now you want to know the remainder. Are you now going to clear? Please, are we getting that? You will clear and you put 18 on 5. Before now you come back, you put the AB plus 2 again. No. Are we getting that? So we have a simple way of doing that. We know always when I substitute what? The numbers here. It gets me what? The number that I'm going to take the modulo on. Are we getting that? So this 18 is gotten from here. So what do? I can take this one and say what? Divided by the 5. So that if I have this, anything that I put here is already in the modulo. Because that thing then divided by 5. Because here we said what? 1 operating on 2 is what? A is 1, B is 2. So it will 1 times 2, which is 2 plus 2. That is what? 4. And 4 mod 5 is what? The 4 here. So after you get the answer, we take the mode. And the mode is division by what? 5. So the simplest way, you can also do this. Or the simple thing that you can do to help you is that you can also always take what? The machine, then you divide by what? The modulo, to be part of the formula you are going to put on the calculator. So that the answer that you get, that is already in the what? Modulo for the remainder. Are we getting that? I know you are confused. See what I mean? Check this. So I have the machine to be, AB plus 2. Now I'm going to divide this AB plus 2 by 5. Meaning I'm taking the modulo, which is the 5 on this. Please, are you getting that? So my formula I'm going to put now is to be what? AB plus 2 all over 5. Please, are we getting that? So that when I'm solving and I put what? AB, some people after getting the AB, they will just, or after getting the answer for the binary, they will just put it here, forgetting that modulo is attached. Are you getting that? So since after I've gotten the answer, I will divide by the modulo. Are we getting that? What am I saying? I'm also saying that you can just take what? The machine, which is getting you the number, then divide by what? The 5. Are we getting that? So meaning this AB plus 2 is the binary and division by 5 is what? I'm taking the modulo. Do we get that? So this one, if I put it on the machine, I'm going to have, so we said over 5. So I'm going to have the AB alpha B, then plus 2 all over 5 on the calculator. AB plus 2 all over 5. Are we getting that? Then I click on the card. So after clicking on the card, now I have what? A question mark. A question mark. Then what do? I put the A value. So I have 1 by what? The 1. It's not just by 1 operating on 1. So I will have what? A1 equal to B also what? 1. Then equal to. Then I have 3 on 5. So the 3 on 5. 3 on 5. Since the denominator is the 5, which is the modulo, the remainder is what? The 3. That's why we are having the 3. Are we getting that? Are we okay? So we even said that when the number is smaller or when the modular is bigger than that of the number, we write the number as an answer. Are we getting that? So that's why this one is getting us the 3. And let's continue. I want to do for this. So putting this one, I have what? 1 operating on 3 to get this. So I'll have A to be 1, then B to be 3, then this one is getting me what? 1. So meaning the answer is what? 1. So this one means what? It goes into that what? 1 exactly. There is no what? Remainder. Because this one is going to be 1 times 3, that is 3 plus 2, which is 5 on 5. And this one, 5 into 5, 1. What is left? 0. Please, are we getting that? Okay, so that is why we are saying 0, because it goes into 8 what? Exactly. We get the remainder 0 when it goes into 8 what? Exactly. Please, are you getting that? Okay. Then now, let's imagine we want to do for this. So now I will get what? A1 and D4. So 1 equal to then 4 equal to. Then I convert it to what? My main fraction. Then the remainder, the denominator is 5. I have one whole number, 1 on 5. We know this one is the same as the modulo. So the remainder is what? The 1 here. Are we getting that? So we can see through that this one already caters for the modulo and the binary operation. Are we getting that? So for exams pressure not to avail, all that I'm trying to mean is that whenever you are given, divide the modulo by the distance. Whenever you are putting it on the calculator. If you are also sharp enough, what can you do? You can just put what? This one. The number that you get, you take the modulo on. Likewise we were doing in the first place. Are we okay? So the one that you think it will help you, you use it. Some people are saying, say, me, let's take what? The binary operation first, then we take the modulo on the number we will get. But sometimes examination pressure, you will take it and you will forget to take the modulo on. Are we okay? That's why I'm dividing by the modulo. Meaning what? I've added the modulo to the distance. And you see when we were doing, we had it to be the same. So let's imagine we want to do for this. Let's see if this one is going to get us the 3. That is 2 and then what? 3. So I click on equal to, A is 2, then B is what? 3. Then I have what? 8 on 5. Converting it is what? 1 whole number, 1 over 5. The denominator is 5. The numerator is 3. That is the 3 here. Please, are we getting that? Since I'm already having the division, I'm good to go. I want to do for, let's imagine this one and see. That is 4 and 3. So A is what? 4. Then B is what? B is 3. Then that one too is getting me 14 on 5. If I convert, I get 2 whole number, 4 on 5. And the remainder is what? The 4 on top. I think you can see because the denominator is the same as the modulo. Are we okay? That is that. You can do that. Are we okay? Okay. So let's now proceed. After we are done with the calculator, what do we now do? We are going to solve more examples so you understand what I mean. Don't worry, very soon. So now, they are saying that this is our A. Now they are saying that for the B, we have to use this table in solving this. So I'll say B. Let me put it here. B. Then I. BI also says what? Evaluate this. We have to evaluate this. And this is what? The law of odd mass. The law of what? Board mass, right? That is, you solve brackets first. So this one and also this one before you add the final answers, right? So let's see. 2 star 1 is equal to 2 star 1 is equal to. So let me write it. 2 star 1 plus 2 star 3. So which is equal to 2 star 1 is equal to 4. So I put the 4. Then I have here what? Plus. Then now I have 2 star 3. 2 star 3 is also giving me 3. Then when I convert this, we are working everything in modulo. Do we get that? So this one will get me what? 7. Then I take what? Mod 5. Because this 7, we are working in modulo 5. 7 is not part of the remainders of what? 5. That is why I'm taking the modulo of the 7. Are you getting that? And taking the modulo of the 7 will now get you that is 2 as what? As an answer. Please, do we get that? So now we have 2. We took this, it was this, plus, then this is that. Now we are having 7 in mode 5. 7 is not in mode 5. Then we took the mode 5 of the 7 and it is giving us what? 2. Please, are we getting that? Okay, so that is that for the first one. That is that for the first one. So even somebody can even choose to say that, oh, 7 is equal to what? 2 in mode 5. I think you know this. Yeah, 7 will give us 2. Whenever we take mode 5 on 7. Are we getting that? So this one is the same as this one. Okay. So that is that for this example. Do you understand? Shall we take example number 2? Calm down, you understand everything, eh? Okay. So example number 2 also says we have to do what? Example 2. And operation star is defined by n star n, which is equal to 1, 3, 5, 6. And the table says I have this 1, 3, 5, and 6. 1, 5, then 6. So I have it this way. I have it this way. Then you were giving 3, 5, 0, 6, 4, 3, 5, 0, 1, 4. So an II is saying from the table in I. Find the true sets of A. 3 star n, which is equal to 3, and B, n star n, which is equal to 4. Then solution. Okay, before we come to this particular question, you see, because I'm in hurry, please forgive me, you see, because I'm in hurry, I forgot to solve what? The example number 1, the II part, I didn't solve it and I've written what? Example number 2. So please, it's still on the board. Quickly, I want us to solve that before we move on to what? Example number 2. Sorry. It escaped me. Are we getting that? Please and please forgive me. So can we come to that one? We solve that one before starting with example number 2. Okay. So that one says we have to find the true set of this. Are we getting that? So we have to find the true set of this. And to find the true set of this, what do we do? Meaning we are saying that a certain value of n, when we operate it on 3, then the result, we operate it on the same number we picked, it should get us 3. Are we getting that? So this one is not just easy when you do inspection. A situation whereby you go towards the table, and I've even cleaned the table too. Let me construct the table. And I think you are having your table. I have a star here. Then I have 1. So that is what we had, right? So I want us to, based on this, to solve it. So we don't know the n, and the possible values for n can be 1, 2, 3, 4. So here what do? We can inspect, or we can pick the first one. So that is what? Let's imagine if n is 1. Let's see if it will work. So we say what? If n is 1, first of all, we know we have to solve for the bracket first. So we have this, which is n star 3, and 1 star 3 is 0. So taking this 0, then we are going to have what? The same 1 we chose for the n. Then what? Star, the answer that we have for this. So we are saying picking n to be 1, here is 0. So we will have what? This 1, the same 1 star, the 0. So 1 star 0. 1 star 0 is even on here. Please, are we getting that? So you see, doing mere inspection isn't easy. Are we getting that? So what do? We pick when n is equal to 1, because we have 1, 2, 3, 4. N can be 1, can be 2, can be 3, can be 4. So when n is equal to 1, what is it getting us? We can say that it will get us 1, then star what? Into bracket 1 star 3. Then solving this one will get us 1 star what? 1 star 3. 1 star 3 is getting us what? 0. Then 1 star 0, we have 1, we don't have 0 here. So this one is what? Not defined. Are you getting that? Because this 0 is not in the set here, or is not part of what? The set given. So we have the 1, we don't have 0 here. So it is what? Not defined. And I think you are okay with this. So let's proceed. Then when what? So meaning 1 is out. When n is equal to what? Then we come to the next one, 2. Then this implies that we have 2 here, then the star, then into bracket the same 2, then the star, then I have 3. This one is equal to 2 star 3. 2 star 3 gives us what? 3. So I will have the 2, then the star what? 3. Which is equal to, because this one gives us what? 3. So 2 star 3. So 2 star 3 again is giving us what? 3. Are we okay? So solving this one, 2 star 3. 2 star 3 is 3. So we have 2 star, then the 3 here. So the same thing is going to get us the 3. Maybe 3 or 4 will also get us what? 3. So let's verify the remaining 2. So when n is equal to 3, then this implies I will have what? 3 star, then 3 star, then 3. So this one is equal to 3 star. So 3 star. Then 3 star 3, so 3 star 3 is 1. So I will have 1, which is equal to 3 star 1. Where 3? 3 star 1 is now what? 0. So this one is also not part. So when the last one, n is equal to 4, which is the last one, let's see what that one will get us. Let's imagine I want to put it here. I want to put it here. I want to put it here. We're already done with the I. So I want to put it here. So that one too implies that 4 star into bracket 4 star, then 3 is equal to, then it will get me 4 star. 4 star 3. 4 star 3 is 4. So I have what? 4 here, which is equal to, then 4 star 4 is equal to 3. So this implies that n is equal to, when n is equal to 1 is out, when n is equal to 2, we had it, is equal to 2, or that is 4. Then, for you to be able to know the values for n, now I think you can write a true set. Please, are you getting that? Please and please again, please forgive me. I was supposed to do that one, but I thought I gave you only the I. Are we getting that? That is why I reconstructed this thing and I was checking. You see, this one you can't do what? Mere observation. That is why we did what? We took one, and we've done something of this sort before, right? So I think that is that. Okay, so now, can we now begin with our example number 2? Yeah, we can proceed to our example number 2. Our example number 2. So that is that for this one. So, example number 2 is saying something. It is saying that the operation star is defined by n star n, which is equal to mn plus 2, the same thing as what we were doing with the machine. Okay, in modulo 7, now we are working in mode 7. So we have to copy and complete the table on the operation set, that is this. We have to copy and complete for this one. Let's see if it will go here, it won't go here, so I want to write it here. So we have to copy and complete, that is the I. So I can put my I, then I copy the table, that is 1, 3, 5, and 6. 1, 3, 5, and 6. So that is that. So already we were given what? 3, 5, 0, 3, 5, 0, then 6, 4, then 3, then 5, 0, 1, then here 4. Yeah. So shall we now start? Now this one we are working it in what? Mode 7. So do I have m and the n on the calculator? No. That is why the previous one I was referring to what the x and y. So always you can choose to represent them in what? X and y. You have to know that the first is for x and the second is for what? Y. We don't have m and n. But the first example we were having what? The a and b on the calculator. That is why we put that. So this one we are going to represent them in what? X and y. Are we okay? So the machine is what? X, y plus 2, which is the mn plus 2. So I'll come to my calculator. Then here, since we are in mode 7, I want to attach that so that I get to see the answer I'm having is in the mode. Then to do what? You put this one, then what do? We are going to finish putting this one, then the answer, we take what? The modulo on that. Sometimes we forget. So I want to put this one, then divided by the modulo. Are we getting that? Okay, so what do? I have the fraction sign, then the x, y, then plus 2, all over the mode is 7. Then I click on my calc. So then I have x, waiting for x. So now I want to verify sum of what I've been given. So I have here to be what? 3. Let's check if it will get me the 3. So that's 1, 1. So I'll put 1, y to 1. Then I have 3 on 7. 3 on 7, the denominator is what? 7. And the down is what? The top is what? 3. Please, do we get that? So on that note, we can say that the remainder is what? 3. It is just whole number, no base fraction. This is the proper fraction. We were always interested in the proper fraction. Then if the denominator is the same as the modulo, we take what? The top. That is why here is what? 3. Let's see that of this one. So x is what? 3 now, and y2 is 3. So 3 for x, then y2 is what? 3. Then it is getting me what? 11 on 7. So I convert it to what? Now I have one whole number 4 over 7, and the remainder is the 4. Please, are we getting that? Let's check this one. Or we can even check this one. Let's check this one. So that is 1 and 5. So equal to x question mark has come to 1 equal to the y2 is what? 5, which is equal to, then I have 1. So since we have 1, you can't say the 1 is supposed to be the answer, meaning it goes into 8 words exactly. That is why it is getting you what? A whole number. So when you divide and you get the whole number, meaning there is no what? Remainder. It could be what? 7 over 7. That has cancelled to get what? It will go into that what? 1. So the remainder here is what? 0. That is why here is what? 0. So when it goes into 8 exactly, don't put the 1 there as the remainder that is supposed to be here. 1, meaning there is no what? Remainder. So anytime you divide and you get what? The whole number as an answer, meaning the remainder is what? 0. Please, do we get that? Shall we now proceed to see through why they are saying here is 6? So I have 6 and what? 3. So you put that one to, let's see. So equal to x is now 6 and the y is what? 3. So I get what? 20 on 7, I convert. There is two whole numbers, 6 on 7. So the remainder is 6. Now it means what? It works. Are we getting that? So now we can use it to fill the potholes. So I've copied, now I want to complete. Are we okay? So what do I do now? I think I want to put here, so that is 3 and 5. So equal to x question mark is what? 3 and the y is what? My 5. So that is 17 on 7 and I convert it. Yes, now what? The remainder is 3. Then the next one, that is 3 and 6. So question mark, I put 3 equal to, then y question mark has come, then 6 equal to, then I have 20 over 7, which is 2 whole numbers, 6 on, so here is what? 6. Please, do we get that? Then we want to proceed to here. So this one, now I don't think about what? The modulo again, because that one too has been taken into what? Consideration. Are we okay? So now I have this one and this, so that is 5 and 3. So x question mark 5, which is equal to then what? 3, which is equal to, I have 17 on 7, I convert and I get the remainder to be what? 3 here. Then this and that, that is 5 and 5. So I come to my calculator, x question mark 5, which is equal to then 5, which is equal to. Now this one too is getting me 27 on 7, so I convert. Then I have 3 whole numbers, 6 on 7. The remainder is what? 6. Please, do we get that? Okay. I'm speeding now because I know this one, you already know that. Okay. Then I want to solve for this. That is 5 and what? 6. So I will have x to be what? 5 and y to be what? My 6. So that one too is getting me 32 on 7 and I convert to get 4 whole number, 4 over, so the remainder is the 4. Are we okay? Then proceeding to this one, that is 6 and 1. So x 6, y what? 1 is equal to 1 whole number, so the remainder is 1. Are we done? Oh, we are done just like that? Oh, sorry. So that is not for this particular table. Are we okay? So now we've copied and completed the table. And they are saying that from the table in I, that is this I, what do? We have to find the true set of this and also what? This. This one we can do mere expression, we can do mere expression, and this one too we can do what? The same thing. Are we getting that? Because this one is not complicated that we can find. We are only asking that, let's come here. That is the I. That is what? The II. They are saying that IIA, 3 star what? Certain number should be equal to 3. So 3 star what number is equal to what? 3. So this implies that it will be 3 star. Then we go to the distance and check. 3 star 1 is equal to 3. No. 3 star 3. No. 3 star 5 is equal to 3. 3 star 6 is not equal to 3. So it's only 3 star what? 5 that is equal to what? 3. So this implies that my n is equal to what? 5. So then, therefore, the true set is what? N is such that n is equal to what? 5. Isn't it easy? Then what was out of the second one, which is the B? Now that one to say is what? M star M is equal to 4. So this implies that what number operates on itself to get 4? Are we getting that? So we have 1 operating on 1, 3 operating on 3, 5 operating on 5, 6 operating on 6. So which one operates on itself to get what? 4. So that one too we can just what? Express. Okay, so I have what? M star M. So 1 star 1 is what? 3, not 4. Then we come to 3 star 3. 3 star 3. That one too is what? 4. Oh, so we've gotten 1. Let's proceed and see if we are going to get another one. Then I have 5 star 5. That one is 6. Then let's check that of what? 6 star 6. That one too is what? 3. So it's only 3 star 3. That is what is getting us what? 4. Please, are we getting that? So we can say what? This implies that 3 star 3 is equal to what? 4. So this implies that M is equal to 3. Then we say what? Therefore, M is such that M is equal to 3. And that is that. Please, do we get that? So that is how to solve this one too. How to fill the table is what necessary. If you get the table wrong, everything you are going to calculate will be what? Wrong. Because after the table, we are going to use the table in answering all the questions. So please and please again, like what we were doing, this one too, somebody can also say what? Say me, the division by the distance, I don't like it. Are we getting that? So what can you also do? You can just write your xy, what is what? Alpha x, alpha y, then plus the 2. Then you begin calculating. So I'll click on the cap. Then I want to solve for what? Let's say this and that. So 1, 3. So I put equal to. So 1 for x, then 3 for y. Then I'm having what? 5. That is what is here. 5, then you say mode. 7 is 5. Then we come to what? Let's say this side or this side. Then that one to 1 operating on what? 5. So I have equal to, then x1, then y what? 5. Then that one too is getting me what? 7. So meaning I have what? 1 operating on what? 5 is what? 7. So 7, mode 7 is what? 0. Please, are we getting that? Let's imagine we want to what? Do for, let's say, this one. So that one is what? 6 operating on 5. So I'll have equal to x is 6, y is also what? 5. Then click. That is 32. Now you say what? 32 mode what? 7. That is 32 divided by 7. Are you getting that? So now you see you are going to divide to get your remainder. So why didn't you introduce the division by 7 already? Are we okay? That is why we normally do that. So it's what? The AB plus 2 or the MN plus 2. That is what is getting the 32 all over the 7 for the mode. That is why I divide the formula by what? By what? By the 7, which is the modulo. Are we okay? So when you do that, it's a 32. Now you are having a 32. So now you're going to clear the formula you put in doing the calculation and you solve this one before you come and put the formula again. When are you going to finish? That is why it's advisable to stick to what I'm saying. Are we okay? Okay. So that is that for example number 3-2. Example number, is it number 2? Yeah. So can we now move to example number 3? Let's move on to example number 3. Example number 3. And example number 3 also says that operation. Then lastly, what is it? Roman numeral 3. That one to says into bracket 4 star F star 4 is equal to F. Okay, so I put my solution. The first thing says I'm to copy and complete, so I want to copy this. So that is my A. So I have my star, I have my 2, 4, 6. 2, 4, 6. So I have it this way. Okay, I was given here to be 4, here to be 8, here to be 2, and I have 6 here. Then they are saying something that to complete this we use the binary operation. Where is it? M star n is equal to the unit digit in the product n. So when we multiply m by n, the answer that we get, we are interested in the unit what? Value. So let's imagine we multiply and we get, let's say, 3, 4, 2. This is units or ones, tens, and also what? Hundreds. So this one will be what? The units. Are we getting that? So then I'm going to write 2. If I multiply and I get 84, what do I do? This is the unit part of the 84, so I'm going to write a 4. Please, are we getting that? Okay. So it is saying that m star n should be equal to the unit digit in the product mn. So when I multiply m by n, the answer that I get, the unit part of it, is what I'm supposed to use to fill what? The table. That is what the operation star is defining. Please, are we getting that? So I come here, I want to verify if what they filled is true before you proceed. You don't just read, then you begin to fill. Are we getting that? Test for those already given to you. If you're able to get the same answer, then meaning it works. So what are we doing? We are going to take these 2 and multiply by these 2. So 2 by 2 will get us the 4. Then I have 2 by 4 will get us 8. 2 by 6 is getting us what? 12. And the unit part of the 12 is what? The 2. That is why here is 2. This one is what? 4 times 4, which is what? 16. So if here is 16, the unit part of it is what? This. That is why here is 6. Are we getting that? Let's now proceed. So this one, I have this by that. So 4 by 2 is getting us 8. Already it's a unit. Then I have 4 by 6, which is what? 24. The unit part is what? The 4. Then I have 6 by 2, which is 12. The unit part is what? 2. Then 6 by 4, 24. The unit part is 4. Then 6 by 6, which is 36. And the unit part is what? 6. Please, are we getting that? So that is what they mean. You multiply the numbers, we are interested in the what? Unit part of the number. You get as an answer. Are we okay? Okay. So let's now look at something here. So now we are done with the A. And the B says we have to use the table to solve the operation x star 4 should be equal to what? 8. So let's check it. This one we can just observe or investigate together. Are we getting that? Okay. So we are going to do mere observation. So this one is what? X star 4 is equal to 8. So x star 4 is equal to 8. This one implies that what will be our x? So we go to this thing. X can be 2, 4, or 6. It can be any of these. So we are going to inspect for what? All. So we are only going to do what? Inspection for this one. So I have 2. Then operating it on 4. So 2 operating it on 4 is getting us what? 8. So x can be what? 2. Are we getting that? We can also check for the other. 4 operating on 4. If x is 4 operating on 4, we'll get us 6. No, it's not 8. Then the last one. 6 operating on 4 is getting us 4. That one is also not what? 8. So meaning what? X can be what? 2 star 4 is equal to what? The 8. So this implies that, or therefore, x is equal to what? 2. It is only when what? X is equal to 2, that is when we will get what? The answer 8. Please, are we okay? So that is that for the first one. Let's move on to the second one. Let's move on to the second one. So that is our II. So the II is also saying what? E star E is equal to E. E star E is equal to E. So let's see. This implies that what number operates on A set to get A set from the table? So let's see. 2 star 2 is getting us 4. No, it's not getting us 2. Let's come to 4. 4 star 4 is also getting us what? 6, but not 4. Then 6 star 6 is getting us 6. So it's only 6 that operates on A set to get what? A set. Please, are we getting that? So I can say 6 star 6 is equal to 6. So therefore, E is equal to 6. Please, are we getting that? Isn't it simple? Let's do for the last one, which is what? The III. That one too says what? Into bracket 4 star F star 4 is equal to F. So this one we are having MF, solving something in bracket, operating it on this to get that. So please, this one we are going to also what? Verify for all. But this one we write when them things. Are we getting that? So let's write when, because just inspecting it from here, you are going to take a product, then you operate it on it is going to be tedious. That's why this one we are showing the workings. Are we getting that? Okay. So when what? What will be the possible value for F? For operating on that. So it should be all this because already 4. The first one is for this side. And the second one is always for this side. So meaning we are taking this side. Are we getting that? So when, and this side is the same as this side. So when what? F is equal to, let's say, 2. That's the first one. If F is equal to 2, then this implies that I will have 4 star 2. Then star what? 4. Then what is it getting at? So I will have what? 4 star 2. 4 star 2 is 8. So 8 star, then what? 4. 4 star 2 is the 8, then star 4. So let's see. Are we having 8 inside here? We don't have 8 here. Please, are we getting that? We don't have 8 here, neither here. So what are we saying? This one is not what? Not defined. Because this 8 is not part of the set. Are we getting that? Okay. So then let's take the meaning 2 is off. When F is what? The next one is 4. Then what do we say? This implies I will have 4 operating on 4. Operating on 4, which is equal to. Then 4 operating on 4 is getting at 4 operating on 4 is 6. We have 6. Please, are we here? Then star, I have my 4. Then which is equal to. Then 6 operating on 4 is getting you. 6 operating on 4 is getting us what? 4. Are we okay? Okay. So let's see something. When F is equal to 4 here, after solving this, we have the same F to be the answer. So can you see F is what? 4? When we put 4 here, after solving, we have 4. Are we getting that? Okay, so this one can be 1. Let's check for the last one, if that one too is going to give us the same answer. Okay, so when F is equal to what? 6. Then what do we do? When F is equal to 6. So what do we do? So we say this implies that I have 4 operating on 6, operating on 4, which is equal to, then 4 operating on 6. 4 operating on 6 is what? 4. So I have 4 operating on 4, and which is equal to 4 operating on 4 is what? 6. So let's now proceed. So we can see through that when f is also equal to 6, after operating it gave us what? 6. Are we getting that? When we put f here, the final answer should get us f. So we put what? F to be 2, and the final answer also got us what? Undefined. Then we put f to be what? 4 inside what? This, and it gave us what? 4. So this one is 1. And putting f to be equal to 6 also inside, it gave us what? 6. So we can say this one too is what? Another one. So we can say that, therefore, or this implies that f is equal to 4 or 6. So it's only when x is equal to 4 we get what? An answer 4 from this machine, or x equal to 6 we get us what? An answer 6. Please, are we getting that? So that is that for this one too. Please, are we okay? So here all that we were doing is what? Doing the expression. Are we getting that? And some of the expression you have to what? Show working, because just doing mere expression and sometimes it is tedious. Please, are we getting that? Okay, so that is that for example number 3-2. Example number 3-2. Then I have the last example with you. Then we'll say bye bye. Last example with you. That is example number 4. So let's write that one, and that one maybe I will solve. Are you getting that? So example number 4, and that one says the operation star is defined by A star B, which is equal to A into bracket B plus 2. In arithmetic modulo 8. A. Prepare a table for the star on the set P is equal to 1, 3, 5, and 7. Then B says from your table from our table, what are we supposed to do? From our table, what are we supposed to do? From our table, I evaluate three star 5 star 7. I find the solution set of n n squared is equal to n. So now we put solution, and you know, this one I won't solve. So after you are done solving for the A, and you are using the table to solve the B, for the B you are supposed to get, if you solve the B, A is the table, and for the B, BI, after you are done solving for the BI, you will get 5. And that of the II2 answer, you will get just 1. So you get n is equal to 1. Okay. And that one, you have to find the solution set. So it is going to be this. N is such that n is equal to 1. So that is what you are going to get for the second one too. Please, are we getting that? We have so many examples in the Aquila. Please make sure you solve them, or any pamphlets you are having, solve them. And should in case of any question for Sir or for me, you put it in the comment section there. Also, when you go to the introduction to the channel, you see after everything, my information was provided, or before everything, my information was provided. You go there, you can see my number over there. Then you can WhatsApp me with that. So this is the last video lecture for modular arithmetic. Are we getting that? So in our next meeting, we are going to be looking at what? Another topic. Are we getting that? Okay. So on that note, bye bye. See you.